Guys. Today I just want to take a little bit of time to introduce you to some properties of quadrilaterals and how to identify them. Okay, so essentially if you had a lineup of different, quadrilaterals, that you guys would be able to tell which one was which, okay? And a lot of you guys should be able to do most of these, so most of this should be a review. There will be more specific things about each one of these, so I'm going to go through, trapezoids and kites and parallelograms and rectangles and squares and things. There will be more advanced things about all of these. So this is just a brief overview, it's an introduction to these things, and we will kind of get to the more clinical stuff in the coming weeks. So things you should already know about quadrilaterals. You guys know that they have 4 angles, 4 sides, 360 degrees altogether. You guys probably know the area formulas, your base times height, your length times width. You guys should know the regular quadrilateral is a square, and also things like like little things we've done throughout the year, like we can put them inside circles, right? Like that was like a big thing that we did, right? We put squares inside circles and things like that. We talked about that a little bit. Right? We did inscribing, right? But also things like for a lot of these, when you have rectangles and squares, you can go ahead, you can make the Pythagorean theorem apply, right? A little right angle there. And one that we definitely covered earlier this year, we said was kind of the original problem, is when we had a square and we wanted to find a diagonal, right? That's where we talked about irrational numbers and whatnot. So, we talked about how, right, this was a ratio of 1 to 1 to the square root of 2, right? So again, we've talked about them. A lot of this is not going to be new for you guys. I'm going to write in blue today because Emma made her own website, and it's very, very colorful, and mine is very black and white, so I have to step my game up, right? So I'm writing blue today, living life on the edge. Okay, so our first one we're going to look at is a trapezoid. Now, a trapezoid is a quadrilateral. Now, we know the quadrilaterals have 4 sides, right? So there's just, the random kind of shapes, right? If you just put together 4 sides, there's the 1, 2, 3, 4. There's not really any properties about this, that we know. Something like this, there are, just the random kind of shapes that we can draw, right? That we don't really know anything about except the basics. That there's 360 degrees, that there's 4 sides, and there's 4 angles, right? So the trapezoid is the first one we can classify because it has something that we can go ahead and point out, and that is that it has one set of parallel sides. Okay, so these 2 sides are parallel. Okay, and from that, using a lot of those properties we've talked about best, we can tell a whole lot about trapezoids. Okay, now your regular trapezoid, that's all you know, right? But more advanced, we have what's called an isosceles trapezoid, and an isosceles trapezoid, you have this, right? Like an isosceles triangle has 2 sides being the same, an isosceles trapezoid also has 2 sides being the same, okay? We call these the bases, okay? So the top can be the base, and the bottom can be the base, okay? And the outside we call them legs, okay? Call them legs, okay? And a lot of times what we're going to be able to want to find is the height. So the height's going to be super important for us, okay? So it'll be, right angle, right? So again, what does that tell us? Oh, look, a right triangle. All of a sudden, that becomes very, very useful. Pythagorean theorem, trigonometry. Okay. I think about isosceles trapezoids. If we kind of cut off one of these parts and cut off one of these parts, and if I were to kind of pick this piece up, flip it around, and put it here, it would actually fit perfectly in here, and we'd have a rectangle. So that makes isosceles trapezoids a little bit easier to work with. We want to know these vocabulary terms because they might put it in writing, right? They might say, this is an isosceles trapezoid, and you're going to have to know, hey, that means that these sides are congruent and these sides are parallel, okay? All right, kites. Let me tell you something. We didn't have kites when I grew up. It was like a shape that we classified. It had properties, but it didn't really. We didn't really ever call it a kite. So I thought that's something I missed out on when I was a kid. So when I was your age, it was just a shape. Okay, a kite has 2 sets of congruent sides. So not necessarily parallel, but 2 sets of congruent sides. And what's going to be unique about kites, and we'll talk about this more advanced when we get there, is that when you go ahead and you kind of cut these things in half, you create right angles. So it makes it look much more like a kite. I know kites are not something that kids play with these days, but yeah, it makes some right angles in there. So again, see your right triangles. We have similar triangles, congruent triangles and things like that. So that will be important for us. They'll bisect each other. Okay. All right, now let's get down to nuts and bolts and things we're probably going to spend the most time talking about, and that is parallelograms, right? We've been talking about this last week, all about parallel and perpendicular lines. Well, there's all, just take a second to look at it. All parallel and all perpendicular lines, okay? So, for today, the very basic things you need to know about a parallelogram. It has two sets of parallel sides, okay? And also, the opposite sides are congruent. Now, there's about 1 million more properties that we're going to learn, but for today, that's a start. Two sets of opposite sides that are both parallel and congruent. Okay, that's it. There will be tons more. I have a whole sheet full of them that you guys are going to go through. Okay. All right. Now, in the parallelogram family, there's these two things. Okay. From here, you can either go to rectangle, you can go to rhombus. Now, a rectangle is a parallelogram. Everything on this page right here is a parallelogram. A rectangle is a type of parallelogram because both of those things that we just said are true. Are these sides parallel and congruent? Yeah, and you guys probably knew that, right? Good. So, is it a parallelogram? Yes. It has the added caveat, though, that all of your angles are 90 degrees, okay? And what you'll see in the future is that that's going to tell us something. Something about the parallel lines and things like that. A rhombus over here, right, is also a parallelogram. So all those things are true, right? These sides are parallel, and these sides are parallel. There's just one extra nugget of information, okay, and that's 1, 2, 3, 4. All your sides are congruent as well, okay? So again, where they differ, they don't have to be 90 degrees, okay? Please remember that all the sides are congruent, the angles are definitely not. This is still an obtuse angle, this is still an acute angle, okay? All right, and we kind of bring it back together with a square. Square is the regular quadrilateral choice. Everything that's true about all of these things is true for a square. So is it a parallelogram? Yes. All right, you have two sets of parallel sides, right? Are the opposite sides congruent? Yes, but like a rhombus, all the sides are congruent, okay? And your angles, all 90 degrees, okay? So again, if it's a square, if we say this shape is a square, then is the square a rectangle? Yes. Is it a rhombus? Yes. Is it a parallelogram? Yes. A square is all of these things, okay? And to be even more specific, all the properties that are true about these shapes are true about a square. All the properties about a kite, generally speaking, are also going to be true about a square. All the things that are true about isosceles trapezoids and regular trapezoids are also going to be true about a square. So it is kind of like the ultimate shape. So I found this little thing. I'm going to put a link to it on the website. But pretty much, hey, is it a quadrilateral? Yes. Then could it, what, other than just being a kind of an amorphous blob, like what could it be? It could be a kite, or it could be a trapezoid. Oh, if you see the word trapezium, just run. Okay, that's what they use over there in jolly old England. It is not the same shape that we talk about it. They have different definitions. I will on the website. You can kind of explore that. I didn't want to bring it up because I didn't want to confuse you guys. They reversed their definition. So if you see trapezium, just run away. Okay. All right. So if it's a trapezoid, it can be either an isosceles trapezoid or it could be a parallelogram. Okay. If it's a parallelogram, it could be a rectangle. It could be a rhombus. So again, we look at all these things, and it's this kind of complex web, but here it kind of all roads lead to Rome kind of thing, right? All things lead to a square. So the square is kind of the ultimate shape where anything that's true about any single one of these shapes is always true about a square, okay? So again, is a square a rectangle? Yes. Is a rectangle a parallelogram? Yes, it is. Does a rectangle have all the same properties as an isosceles trapezoid? Yeah, it does, okay? Again, think about it. Are the two bases parallel? Yes. Are the two sides congruent to one another? Yeah, they are. So generally speaking, would we classify rectangles as trapezoid? No, but it's important to know that all those facts are true, okay? So again, let's take a look at what you guys have to do today. Okay, they're just going to ask you, which terms describe the shape? Well, this shape, I see two opposite sides that are congruent. Therefore, I know this is a parallelogram. Do I know anything else about it? No. Okay. What terms describe the shape? That is a quadrilateral. That is a blob, right? Okay. So again, these are the types of things you're going to see. Nothing crazy. Which terms describe the shape? Well, that's a rectangle, right? For sure, that's a rectangle. But please remember, rectangles are also parallelograms. Okay. This is, again, turn your head kind of sideways. This is a quadrilateral for sure, but it's also an isosceles trapezoid. Right? It's got a parallel sides and one set of sides that are congruent. Okay, the shape right here, I see 1, 2, 3, 4. Right, that's for sure a quadrilateral. That's for sure a rhombus. Anything else? No, it's not a trapezoid. Right, it's not a rectangle. It's not a square. Okay, the shape right here, I know you want to say kite. It's not a kite. They didn't tell you about the sides being congruent. That is just a quadrilateral. Okay, so again, you guys should be able to do this. This is a square, which is a quadrilateral, which is a rectangle. Okay, good. So you guys should be able to do that. Again, like I said, stick to this. A square is a rectangle, is a rhombus, is a parallelogram. Okay, a kite is going to be its own thing, and isosceles trapezoid is going to be a type of trapezoid. This roadmap at the end is really just to show you about the properties, but not necessarily how we would classify things. So anyway, keep an eye on it. You guys should be fine today. Let me know if you have any problems.